into objects and classes. Here we are dividing it into functions or procedures. Okay. Okay. We are dividing it into functions or procedures, or we also can call that as subroutines. Okay, subroutines. Fine. Now, before we write a program, any program to solve a certain problem. Why do we write programs? To solve a problem. Okay. I want to add two numbers, I write a program. I want to find the roots of a quadratic equation, I will write a program. I want Fibonacci series, I will write a program. I'm trying to solve a certain problem. That is why I write a program. In order to write a program, I need to know the steps to solve the problem. You agree with me? The steps to solve the problem I need to know. Correct? So, an algorithm is an efficient way of telling us what are the steps involved in order to solve a certain problem. Okay, all algorithms should necessarily have a finite number of steps. Algorithm should not go on and on and on forever, or else your program will not be, there will be no end. There is no exit or end point to your program. Okay, how do you represent an algorithm? An algorithm can be represented like 1, 2, 3, step-by-step procedure. Just a step-by-step procedure. Or it can be represented in form of pseudocode, or it can be represented in form of flowchart or Nassy-Sneiderman representations. What we are interested in is flowchart and step-by-step form. Of course, they might ask you to write pseudocode also. You should be able to write pseudocode. Is not a straightforward code. It is a step-by-step procedure. How we represent. This is a step form is in common man's language. Pseudocode has a little bit of code involved, and flowchart is diagrammatic or pictorial representations. All these algorithms. So algorithm is a step-by-step procedure for solving a problem. It should have finite number of steps, which you should not forget. Okay. Finite number of steps, why it should have? Because it should terminate at some point of time, and it should be definitely correct, and it should be well designed. Why it should be well designed, we'll see when we see a flowchart or algorithm. So algorithms, what are they showing us about the program? What information about the program are these algorithms giving us? They are giving us the sequence of events that are happening. They are giving us sequence of events that are happening. Then it is helping us take a decision. It is helping us take a decision. It is also showing us if there is any step that is repeating again and again, the algorithm is also going to show us this repetition. You get the point? So now let us say all of you are RV College of Engineering students. Now I have to pick up somebody. So where does Bhavani stay?
Ma'am in Indranagar.
Okay, Bhavani stays in Indranagar. She is a perfect example for us today. Why I will tell you. Okay, Bhavani stays in Indranagar and she is a student of RV College of Engineering. Okay, Bhavani, how do you come to college? By if for office,
Ma'am, I either take the metro or my driver drops me.
your driver drops you by road,
Yes, ma'am, or I take the metro.
or she takes a metro. Very good, Bhavani. Thank you. So now, what are now if I have to write a step-by-step procedure for Bhavani to come to college, what is the first thing that I do? Bhavani is going to first get up in the morning. Next, she is going to get ready. Next, third step, she is going to have breakfast. Fourth step, she is going to wear her ID card. Fifth step, she picks up her things, right? She picks up all her things, her bag, her lunch, her water bottle, everything, right? Sixth step, now she has to decide whether to ask her driver to drop her or whether to take a metro, right? So she is going to make a decision. That is the sixth step. Now, based on her decision, the rest of the activities will continue. For example, she is going to decide to take the metro train. If her decision is to take the metro train, the set of activities is different. She has to go to metro station. She has to go to metro station. If she decides to ask her driver to drop to college, the set of steps that she has to follow is different. She has to get into the car, check if the car has enough petrol or whatever, the fuel, right? Then she has to check for the route on road to RV college. Her driver will do that. It's okay. Let's say the car, whoever is using the car. Okay. And then reach college. But whereas in metro train, she has to go to the metro station. She has to wait till the metro comes, board the right metro towards RV college, and then reach the college. The two activities based on our decision are completely different. So what happened is Bhavani was actually undergoing a sequence of steps. That is getting ready, picking up her things, everything. At some point of time, she took a decision. And she carried out different sequence of events. We are going back to different sequence of events based on her decision. And while she was taking her decision, there was also repetition of some activity. When she took decision to take a metro train, she went to the metro station. What happened there? She had to stand there. She had to wait, right? Her activity to wait for the metro till it arrives was a repetitive activity, right? She was standing there waiting until the train arrives was a looping activity. It was an iteration. She didn't come down the metro station, go up again and again till the train came. She was standing there in one place and that was a repetitive activity. Correct? When she took a decision to take the car, right? She had to wait till her driver came into picture and asked her to board the car. Correct? She was waiting for her driver, which was a repetitive activity. Once the repetitive activity got over, again she followed a sequence of steps. When the metro came in, this looping or this activity stopped. Repetitive activity stopped. Now, sequence of event is the train is going to stop. She is going to board the train. Then she is going to take a seat in the train. And then again, she is going to wait sitting there till the station comes. Waiting sitting there till the station comes is going to stop until RV College station comes. Correct? So, this way, any activities can be represented as a sequence of activities that involves decision and repetition. All your step-by-step activities might involve this decision making and repetitions. When you represent it as a step-by-step, it should have finite number of steps. If I don't allow Bhavani to end the activity of sitting in the train, she will be in the train forever and she'll keep going forward and forward till the end of metro. Right? She has to get down. The activity of sitting in the train, right, should end as soon as RV College comes. Right? So that is why we need to have finite number of steps. I hope it was very clear to all of you. Okay. Now, the same activity can be represented as pseudocode. This is a well-defined vocabulary. To write pseudocode, we have a set of instructions. We follow that vocabulary only. Vocabulary is a set of words, okay? Like I'm using English vocabulary. That is why I'm understandable to all of you. Similarly, pseudocode has a well-defined vocabulary, but it is restricted. Not like C, not like C programming, not like Java programming syntax. It is restricted. There are well-defined particular finite set of vocabulary for using pseudocode. Same steps can be written in form of pseudocode, or it can actually be represented in form of pictures, pictorial format. So in that pictorial format, if we follow the certain depictions or syntax to use the flowchart, right? There are certain ways that you need to start a flowchart, stop a flowchart. There are different ways of representations in flowchart. When you follow the right representation for a picture in order to depict the flow of a program, that becomes a flowchart. Okay, so for a flowchart, generally you use a top to bottom or a left to right approach. Any flowchart that you read should be read top to bottom or left to right or left to right. Okay, in flowchart generally we don't intersect one line with another. Worst case you want to intersect, we need to use a circuit format. Later you will see that. Okay, generally just keep in mind flow lines or intersection should be avoided. Okay, now this flow chart is also going to depict the communication that is happening between the user and the programmer. Now, what do I mean by user and the programmer? When you write a C program uh, in your lab or on your computer to add two numbers, you are asking the user to enter two numbers to add. Asking the user to enter the number is an activity. It is one step that is involved, and that also has to be represented in the flow chart. When he enters two numbers, that has to be stored in a certain variable entity that entering the number and storing or entering the number also is an activity which has to be shown in the flow chart. Okay, so I will just show you an example of first. I will show you an example of step-by-step procedure. I think I have to share a different window to do that. I think you can see this text document, right?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah, thank you. Okay, so you see this text document here. Now, this is an example of a simple algorithm. Okay, simple algorithm. I maximized it. Yeah, I think you can see it now properly. See here, this is an algorithm which is going to show you the sequence of events that happens when you want to make a telephone call. Okay, when you want to make a telephone call. What is, see, I'm talking about landline, okay, not the mobile phone. When you want to make a telephone call, you start, okay, start. You go to the telephone, you pick up the receiver. Is the next step. Then you listen to the dial tone. If there is no dial tone, then what do? Will you keep the phone in your hand and sit there forever? No, you put down the receiver. You put down the receiver. Okay, it says go to 8. Go to the 8th step directly. 5, 6 and 7 are not involved if there is no dial tone. Okay, when I say listen to the dial tone, if there is dial tone, then you dial the phone number. It is going to check if there is no dial tone. If there is dial tone, you are going to go to the next step, which is dialing the telephone number. Okay, if there is no reply, you are going to dial the phone number. The other person should reply back. the other person should reply back, right? If he doesn't reply back, what do? Will you keep hearing the ring all the time? No, you put down the receiver. Go to 8. If he picks up the call, if there is reply, right? Here I don't write if there is reply again, because if this condition is not satisfied, it is going to 8. If it is satisfied, it is going to execute the next step. You start the conversation. Once your conversation is over, you put down the receiver and stop. All algorithms will begin with a start and a stop. All your flow charts, pseudocode, whatever it is, they will begin with a start and a stop. Okay, now this is the algorithm in common language. Okay, it is a step-by-step way of this is the step-by-step way of depicting a sequence of activity. Okay, now we will, I will stop sharing this. We will go back to our PowerPoint slide wherein I wanted to show the example of a pseudocode. Let me just share it. Okay. Okay. Now I'm going to write an algorithm using pseudocode now. To write using pseudocode, I told you I'm going to use some specific set of vocabulary. What is the specific set of vocabulary is start, print, input, all these things, all these instructions that you see, print, else, stop, then, go to, they are all specific vocabulary that I am using in order to write pseudocode. So if you are asked to write the algorithm, instead of following what I just showed you, plain statements, you can always use pseudocode to write the algorithm. Okay, the same thing. Now this is an algorithm to find out whether a given number is prime or not. Okay, there is a certain logic which is involved in finding out whether a given number is prime or not, right? So if it, see, what is a prime number? 1, 3, 5, 7, they are all prime numbers. A prime number is a number which is divisible by 1 and itself, right? 1, 2, 3, 5, 7, 13. These things, which is divisible by 1 and itself. That is a prime. Okay. So only 2 we call it as co-prime. Don't worry about the mathematics that is involved. You all are very good in mathematics. But for now, logic also you don't worry. See now, what are we interested in? How do we write the pseudocode? First, start, then print, enter the number. What are we asking the user to do? We are asking the user to enter the number. So I print. Where am I printing this? Onto the console window. Okay, what black screen you get after you execute a program, that is the console window. Okay, whatever you have the black screen, the terminal or what you call, that is the console window where you enter the number. If it is you are using an integrated development environment, on the bottom of the integrated development environment, you will get this enter the number. Okay, then when somebody enters the number, it is going to carry out a sequence of steps involved to check whether the number is prime or not. Okay, basically you divide the number by 2 and you maintain the then you subtract it by the number. The quotient you subtracted by the number, whatever remainder you get, you check if it is 0, then it is not prime, or else it is prime, something like that. Logic I will teach you some other day for prime number. We are not into programming it, but the sequence of steps that is involved in initializing, you want to set something, to set a certain variable to a certain value, then you use an arrow mark like this. Okay. Okay, now what is a variable? A variable is something that can store data in it. Okay, when I say n is equal to 2, n is equal to 2, n is a variable that is storing the value 2 in n. Now when I print n, after storing n is equal to 2, if I print n, it will not print the alphabet n, it will print the value 2. So that means in programming, a variable can store data inside it. Okay, here D, I am assigning it to a value 2. Giving a value to a variable is called as assignment. D, I am giving a value to D. If I print D, it will not print the alphabet D, it will print 2. Okay, so it can hold data. It can hold, variables can hold data. The step-by-step procedures that are step-by-step procedure, which is required to find out whether a given number is prime or not, can be depicted in form of pseudocode like this. Okay, so even though we are using 1, 2, 3, 4 step by step, what language we are using inside pseudocode? I'm not aware of the time. Okay, we still have time. Okay, what language we are using inside the pseudocode is the specific vocabulary that is required for us to write the pseudocode. Now it is a restrictive vocabulary. Okay, start, print, input, go to, step. Even though I can understand when I say if r is equal to 0, then print, not prime, else print prime. When I read it, I understand. When I read it, I understand like English. But when can I execute this, giving it to a compiler? No, you cannot do that. Pseudocode, you cannot give it to a compiler for execution. This needs to be converted to a program in order to give it to a compiler for execution. Okay. Now, to make things more simpler, okay, before we forget, flowcharts. A flowchart is a diagrammatic or symbolic representation. You have to use the same representation that we are learning now. Okay, for flowchart. You can't use whatever geometrical picture you like. Okay. The start and stop. Every pseudocode, every algorithm that I showed you, even plain English language algorithm, will start with a start and end with a stop. The start and stop, they are represented by this sleeping ellipse. Okay, this is an ellipse like picture, not exactly an ellipse. You see the two sides of a rectangle are rounded, the entire sides, not just corners. Okay, they are rounded. Ellipse like figure, this is used to represent start and stop. So when Bhavani had to take a decision on whether to take a metro or roadway, then that decision has to come inside a rhombus like this. A rhombus like this. If she says a S, then we will have a line or an arrow mark with the S. If she, okay, if she says a metro, we will have a line or an arrow mark representing metro. If she's, where is my pointer? Okay, we will have a line or an arrow mark pointing set of activities to be executed for metro. If she says roadway, then we will have a line or arrow mark which is going to represent roadway, and the sequence of events below it in form of flowchart is going to execute. All the processes, A is equal to B plus C. D is equal to C divided by D. These are all executing process. These are all processes. These are all operations to be performed. They are all represented by perfect rectangles. Decision by rhombus. Start and stop using ellipse-like figure. Please note this. This is not rounded rectangle. This is ellipse-like figure. No, why I'm repeating it is generally first year students will make rounded rectangles because they will have some stencil and which has a rounded rectangle. But this is a sleeping ellipse like picture. Okay. The input that I enter or output that I am saying, hey, please enter the numbers A, B and C. Please enter values for A, B, C. I will add it and give it to you. All that has to be represented in form of parallelograms. I will add D is equal to A plus B plus C. If I have to output D, print D, that is an output statement. If I say print D, that's an output statement. Even that is represented by parallelogram. And all these fellows, all these representations, all these pictures, you need to connect to one another in order to show the sequence of events. So all these pictures are going to use lines and arrow marks to connect to one another. Okay. See, more about it. Start of or end of a program, right, is represented this ellipse. Computational step or processing of a function, computational arithmetic, b square, d is equal to b square minus 4ac. D is equal to b into b minus 4 into a into c. That is a computational step. That is represented by rectangle. Please enter value for b, a, c. I'm finding the determinant. So b square minus 4ac, right? So that input, please enter the value. Once I find the determinant, print the determinant, print D. That is also output display. Input entry, output display operation makes use of this parallelogram. Decision making is going to make use a rhombus. Okay. Now sometimes it so happens that you are going to write big programs. Big programs in a sense, a program that involves many activities, many decision making. You're writing a simple calculator, it will have many different activities. At that time, you will need to connect. You cannot write it in one page, the flowchart. You will have to go to another page. Use the second page to write the flowchart. If you want to connect flowchart, which you have written from one page to another page, you make use of a circle. You give it a value, you connect it and make use of this value in order to connect it back into the second page. We'll see all these things. Storage can be represented in form of magnetic tape, magnetic disk, etc. Like I told you, all these pictures that you're seeing, they're a part of flowchart. They are connected using flow lines. We don't call it arrow marks actually. They are flow lines. Okay. If you want to write comments, comments are not executable statements. Comments are there in the program for giving information about the person who is reading the code. What would you write? I must be able to understand what you mean, your logic. What are you doing at each statement of C program? For that you write comments. These comments are not considered by compilers. They are for your understanding and my understanding. The person who is reading the program, he should be able to understand how the program works. It is not going to be executed by the compiler. It is not going to be compiled and executed. It is only for information that is there in the program. Okay, comments in the flowchart also can be added by using this kind of a notation. Anything that you want to display. Okay, anything that you want to display, make use of this. Okay, I will show you. Oh, why do we have to use flowchart? Because see, before you write a flowchart, you can actually get to know the flow of program. See, if I want to really judge what are the sequence of activities for Bhavani to reach from Indiranagar to RV College of Engineering, I write a flowchart. I get the perfect flow of her activities, or else it is all scattered. Right? Based on our decision, we get a perfect flow of activities on one part of the program. Okay, and flow chart, it is very advantageous. If you see a certain flow chart, you will better understand what the program is, even if you don't know the programming language. Okay, if there is something going wrong, when she has asked her driver to come and she has reached metro station, there is a problem. There is a problem, I understand. So I have to put go to metro station to the right part of the program and ask her to wait for the driver till the driver arrives near her door in the right part of the program. So you will get to know where you have gone wrong very easily based on the flowchart. That is why you have to write flowchart. But everything cannot be represented in form of flowchart. If the complex logic is very complex, it would be very difficult for us to write flowchart. It will cover many different pages, and you will definitely get confused when you're trying to see what is happening with the help of flowchart. Okay. Now, flowcharts, if you are writing using scale and pencil, okay. Modification and alteration for using scale and pencil itself, I see children don't have erasers. There are so many tools that are available which are helping us write flowcharts. Alteration and modification of flowchart, when there is something wrong in a 4-page flowchart, if there is something wrong in a second page, then the entire picture might get changed based on the decision or based on the looping. You get the point. So modification of a flowchart is a little difficult when you write it for complex logic. Reproduction is also difficult. As and when you're moving from one page to another page of flowchart, you might actually forget initially why you started writing the flowchart at first point. Objective of this problem you will forget. Right? You're trying to find roots of a quadratic equation. If you are using complex logic, writing flowchart again over and over again, by the time you see the determinant is greater than 0 or less than 0, you will forget what you're doing. You will first point forget why you found determinant. Okay, so that is on there. Now one small example to end the class with. No, we still have time, no problem. One very small example, very easy example. All of us know how to find the area of rectangle, correct? Right, Anant?
Yes, ma'am.
Anant? Yeah, we know how to find the area of rectangle, right?
Yes, ma'am.
Okay, Vijay? Vijay is there or he left finally? Vijay, now you are all settled. Okay. So did you understand algorithm flowchart? Okay, Vijay. Fine. Because you were exiting and joining again and again, so I don't know if you were able to follow. Okay, no problem. Sachin?
Yes, ma'am.
Yeah, okay. It was clear now. Okay,
Yes,
so
ma'am.
okay, now all of us know how to find the area of a rectangle. Area of a rectangle is length into breadth. Okay, length into breadth. So if I have to write an algorithm to find the area of a rectangle, I start. Then I read the side length A. There are two sides which we have to take. One is the length, the other one is the breadth. Okay, two sides. They call both as side. Okay, we'll call it side 1 length, side 2 length if you want. First, you have to ask the user to enter the length of first side and store it in a variable called A. There is my pointer. It is here. Okay, it is going to be stored in a variable called A. Next, you are going to find, you are asking the user to enter the breadth and store it in the side B, the length of the other side, which is the breadth, and store it in B. Next, what are you going to do? As a fourth step, find the area. My objective is to find the area. Area is equal to length into breadth. So A into B. Into in programming is represented by that star. You should not use an X. Like you use in mathematics, you should not use X. You should use star in programming for multiplication. Okay. Once you find the area, you have to display the area of the rectangle whose length and breadth are given. So you either use print area or display area. Okay, print area or display area and stop. All programs should start and it should have an end. If your program is executing forever, then there is some problem in the logic. Okay, every program should terminate normally, we say, not abnormally. Abnormally is Control C, Control D that you press in order to stop executing. So that is abnormal end. Program itself gracefully ends after execution of all the statements in the program. That is normal termination of a program. Okay. Now let's write flowchart for the same thing. Start. Sorry, 1 second. Okay, start is represented by this ellipse. Then reading the input A and B is represented by parallelograms. The computational part is represented by rectangle. Area is equal to A into B. You want to display area. You either say write or print or display. Generally, either we say print. We generally say print only. Okay, print or write. Okay, we don't say display here. Right. Okay. So instead of write, you can say print. Print area and stop. All these pictures or all these symbols in the flowchart are connected through connectors. Got? This is a arrow mark. Okay, this is the arrow mark. After start, you read A, then B. This is a sequence of events that is happening. If at all we had a decision, then we had to represent using a rhombus. Okay, so the flow lines are arrow marks with, we call this the blocked edge. Okay, you have two types of arrow marks, right? Pointed edge and block edge. Generally, students use both here and there, but wherever you see, it is block edge like this. Okay, now this is another flowchart example. Why I give you this is once you get an idea of how to write a flowchart, you will know how to write a program. Okay, now this is how your C program you can execute this if you want in your class or in your laptop whenever you're free. How you write a C program. Okay, always you start the C program with hash include stdio.h. This is a pre-processor statement. This is telling the C programming compiler to include the library file stdio.h. This standard input output library file, this is standard input output library file is going to contain the inbuilt functions such as printf and scanf. Printf and scanf. We are only using the function, giving it parameters and running it. We are not defining the function. How to print on the screen, I am not bothered. I am only telling it to print something on the screen. Okay. For printf and scanf, definition of these functions are given in stdio.h. All C programs will begin with the main. Okay, you can, based on which environment you're working in, this will be a int main or a void main. V-O-I-D, void main. It will be an int main or a void main. Void means the main function does not return anything. Anything. Int means it is returning an integer. Int is integer. Right. Now, okay, getting inside the program. Inside the program, now main is the function that is going to be executed first. Okay, this is the starting point of a program. Wherever there is main in your program, it is going to be executed first. That is the starting point of the program. When I say main is going to be executed first, the statements inside the main program will start executing one by one sequentially. One by one sequentially. What is the first statement for execution? Here we are declaring variables A, B and area which I require to be used inside my program. Inside my program. Why I want A? To store the length of the rectangle. Why I want B? To store the breadth of the rectangle. Why I want area? to store the computation of A into B. We'll find the area and store the value of A into B in a variable called area. What are all these three things? They are all integer variables. Okay, we'll come to data types later. They belong to data type int or integer, which is represented as int. Okay, now before I do anything, I need values for A and B, right? If I want to do multiplication. So I will ask the user to enter the value of A. I will tell him enter side length A. Okay. Printf, you have to use inverted commas, enter side length A and close the inverted comma. /n is to represent if you want the prompt to go to the next line. We use /n. This is an escape character, ESCAPE, escape character, where n has a special meaning. That is new line character. Okay, new line character. It is not the usual alphabet n. Okay, it is a special character which represents new line. We'll come to all that later. For now, just telling you. When he enters the value for A, it has to be stored somewhere. The syntax for taking in an integer value and storing in a certain variable, specific variable, is this. Scanf is the function that is going to take the input and store it in the, and A means it is going to store it in a memory, and A represents the address of where it is stored. So that is why in the very first class I showed you that everything is related to memory and all of the things that we do have addresses associated with it. Okay, in the particular address, the value of that variable is stored. Okay, the syntax is %d. This is, I'll tell you what it is later, but %d we use in order to take in an integer value. If I'm taking in a character value, I will use C. If I am taking in a floating point, a decimal point value, I will use %f. Okay, so %d is used to take in a integer value. Okay, I've taken in A now. The syntax for scanf should be exactly like this. You can't change anything. Okay. Printf, I want to take another length. Similarly, I scan that value, store it in a certain position in that. I take in and store the address of that variable. Okay, there is a comma here. Don't forget. Syntax should be exactly like this. Inverted commas, %d, comma, and A. Inverted commas, %d, comma, and B. Comma and B. Okay. Then I have to do computation. Computation area is equal to A into B. I cannot use area if I have not declared it here. My compiler will say area not found. I don't understand. Right? Compiler doesn't understand if you don't tell it what to do. So if only you have declared it here, you will have this area here. You can use that area there. Okay. Area is equal to A into B is the computation. Once you found area, you have to print. Use the same printf function. Area of the rectangle